Okay, so welcome everyone again to SpaceGeekSpeak. Today we have a speaker that will be talking about creating a prototype of the Martian habitat. Dimitri Gregorski joined BIG in 2013 and has worked on some of the BIG's largest and most prominent projects like King's Cross headquarters, Mars City, and Sluices. He has extensive international experience, having to work on commercial, residential, cultural, and educational projects across a broad range of markets, including United States, UK, Denmark, Singapore, Japan, France, and his native Romania. Prior to joining BIG, Dimitri worked for Kobe on commercial, cultural, and educational projects like Tinberg, I'm butchering pronunciation, library, and the cultural center, and the Pan-European ESS particle accelerator project at Lund University. Dimitri received his Master's of Architecture degree from the Royal Academy of Fine Arts in Copenhagen, Denmark. Throughout his architecture studies, he has worked, his focus of work was on development of flexible buildings in different densities and social landscapes, with a constant outlook on building bridges for the future. Since leaving BIG, he has focused on teaching, research, and establishing his own practice in multidisciplinary community of visionaries. So welcome, Dimitri, to SpaceGeekSpeak, and we're looking forward to your presentation.
Yes, thank you very much. Yeah, it's an honor to be here, and I just wanted to clarify a little bit. I was the project leader of this project. I had the amazing opportunity to work on this, and while I was at BRK Ingalls Group, and this is a work which is in theory the intellectual property of BRK Ingalls Group, because it was developed there. But it is public information already. This has been presented quite a number of times. But it was quite an interesting project because it came not from directly a space, like a space agency, but more came from a country which is trying to kind of break into space, to get involved more into space, and also see space as a generator of solutions for its current problems in the real world right now. As we all see today, like it's getting warmer and warmer, and conditions on Earth are also becoming less and less nice. And then in order to learn this, we've seen that the solutions that are found in space are some of the most, let's say, fast solutions that we can apply on Earth, and they are, let's say, the most advanced somehow. And yeah, and our approach, because we never really had like consultants that were involved in space, was to kind of take a very scholarly approach a little bit, and try to understand both why we are going there, how we are going there, and how can we view it in a historical perspective. We looked at the evolution of our technology and how things are kind of happening now, but also we saw the first step kind of as just the journey, and trying to understand the journey, and trying to understand how people have migrated through on Earth initially, and then how we can imagine, let's say, migration on a different planet. So first of all, we know that fire, so technology has enabled us to migrate on Earth to colder climates. We know also that food and the melting of icebergs were allowed people to kind of occupy larger pieces of land. And we know that also another ice age has forced people down again when the glaciers in Europe kind of came down. Also, we know that a bridge at some point formed, and then we were able to kind of migrate all the way to the Americas, or at least that's the theory right now. But let's say we wanted to be a little bit optimistic, and we know that, let's say, the current estimate that going to Mars would be 6 months. And we wanted, because our client asked us to think of what will be possible in 100 years, we were a little bit optimistic, and we kind of looked at the journey of 3 months and what can we imagine that people could travel over a period of 3 months. And initially, let's say during the Roman Empire, you could travel from one side to the other of the empire by horse. Then, let's say during Magellan's voyage, you could travel. This was one of the first legs of his voyage, all the way to a southern point of Brazil. And he was trying to go around the Earth. Then, by train, you're able to kind of cross the. Now you're able to cross kind of all of Europe, all of Asia. In 4 weeks by train. And even the plane, which is kind of considered now like of a standard of transportation, you could travel anywhere in the world in less than a day. Initially, you used to have quite a lot of hops in order to travel from London to Sydney, for example. So it wasn't like 1-day trip initially. Now you can do it in about 15 hours. And if SpaceX has its way, you might be able to do it under an hour. So we know that the first trip to the moon took about 100 hours, even though like the distance is something which is a bit kind of hard to conceive. It's like many times any distance that was kind of traveled on Earth. And it only took a couple of days, even less than that, because they spent a lot of time in orbit to kind of prepare everything. And we imagine that the whole process going to Mars is going to take about 3 months, and that might be in 100 years from now. And if you think about it, it shouldn't be that different of a journey. It's like traveling by crossing the ocean used to be quite a dangerous endeavor, and people used to do it all the time. And we see that, it's in a way it's nothing new. People have gone through this kind of very extreme travel before. And we hope that in the future, maybe far in the future, we might even be able to, in 3 months, to go from one galaxy to another. But we can only hope. Yes. And then the next step we did is like, okay, so it is kind of conceivable that we can get there. Even though it's hard and there's space radiation and stuff like that, we can kind of conceive that we can make this journey. The thing that we started to consider is what we need on Earth, and how would we need to kind of concentrate that effort when we go to Mars. So we looked at all of the infrastructure that you need to kind of for one person, and then on Earth is about 150 square meters, and somewhere in space you would you could kind of conceivably crunch it down to about 50 square meters if everything is kind of it's done very efficiently. And one of the big realizations that we had is that we will have to kind of think we can't live without food, obviously. So we have to think a lot about also the environment that we have to create for plants. It's not only for humans that we have to create an environment for, but also for plants. So we kind of looked at what are the requirements for humans and what are the requirements for plants, and what are the kind of how does this ecosystem work, and what are the commonalities between us and plants. And also we looked at previous experiments of trying to do this, but we also tried to think, okay, so because we tried to think of like how can you live on Mars without taking any resources from Earth there. So we considered that we have to take ice from underground and to create water. We can use like the regolith and process it in order to make 3D printed bricks, maybe, or create some kind of concrete and create ceramics to create building materials. We need like a different advanced metals in order to create fabrication, to create aluminium, to create glass, electronics, and basically be able to have a society that can produce its own kind of technology. And then we thought about like electrolysis in order to kind of create oxygen from water. Of course, there's also the filtration process from the CO2 in the atmosphere. And then you can create a Sabatier reactor in order to create methane to have fuel for rockets. And then using you need carbon and water to create steel. You can create plastics. You can create fiberglass. And we kind of going through all of these, we kind of realized that we can conceivably have a quite complex, let's say, industry that can produce all of the things that are kind of necessary to have buildings, to have food, and all of these things just so we can sustain life on a long term. And we looked at this kind of sequence of steps of where initially we're going to bring our own buildings, which are probably going to be our rockets. Then we're going to bring machines that are going to build our own buildings. Then the first step where we want to go to is bring nothing. And a lot of people kind of ask like, why Mars? And for example, Venus is also kind of a good option as well. And we kind of try to explain to people like the distances in terms of time, because going to Mars could take conceivably 3 to 6 months. To Venus maybe around 2 months, but going to Jupiter, it's already like another completely different time scale. To reach the Jupiter's moons, it would take maybe like 2 years or 2 to 4 years, depending on how our technology evolves, and then getting to all of these other planets can take even more. Then we looked at, let's say, the forces. So like one thing that we as me as an architect and we in the office of PR Kingo had to consider what is architecture is also based quite a lot on social forces, but also on physical forces. So we looked at like the different planets and what's the gravity on these planets. And we know that on Mars, it's slightly less. For example, on Jupiter, it's actually the gravity can be quite a lot higher than on Earth. So that's quite consideration because of bone loss in lack of gravity. But there's no real study that I know of what happens if people spend a lot of time in gravity, which is much higher than on Earth. Then, of course, we needed to consider the temperature, and of course, one of the big problems on Venus is, even though it's kind of closer, that the temperature can go up to 500 degrees Celsius. It's a kind of a greenhouse disaster on Venus. It can get even hotter than on Mercury, and sometimes, and somehow on Mars we see that the temperature can get up to 20 degrees Celsius, which is kind of a good, nice temperature, even here on Earth, but all the way down to minus 153, and that's considered as something that we could deal with. Then another thing that we started considering, of course, is wind. And the gas giants are where, let's say, the wind force becomes kind of a really, really big problem. It's already like way past like the biggest hurricanes on Earth, like on a different order of magnitude. Then the thing that we kind of discovered as architects, as not people who haven't been involved as much in space development, is that pressure becomes quite it might become a more important force than gravity for building, because on planets that have larger pressure than on Earth, then you need to create even stronger structures, like you go kind of into almost like a submarine type of construction. While on planets like Mars and on the Moon, where you have very little pressure, the pressure that we need to kind of keep us kind of in one piece is something that becomes a force which is much stronger than gravity. Then we consider the sizes of the planets, and let's say the duration of the day. And on Mars, it's quite good. It's very close to Earth. We consider also the tilt of the planet and how that kind of affects our daylight cycle, and how let's say how we kind of spend our days, and our kind of interior clocks as humans. And we kind of going over all of these, we felt like Mars would be kind of one of the best options. In Venus, you can there's some quite interesting solutions how you could live there, but let's say Mars could also give one of the experiences that is kind of the most similar to the one on Earth, because one of our secondary goals in this kind of project was to show people a kind of experience that people would really be kind of excited about having. They should be kind of excited about going to Mars and have a life which is in some way similar to the one on Earth. So it's not a complete shock. Especially since our client wanted to have 1 million people there in 100 years on Mars. We also considered, we looked at like how you can get things there. One interesting thing when we compared Earth and Mars is that they have the same land surface, because on Earth most of it is water. So it's like 4 million kilometers off, but it's still pretty close. Then the gravity is lower, so that in terms for construction, that will be an actual advantage, that you need kind of less material to build things. The inclination is similar in terms of weather, in order to create kind of a similar cycle. The magnetic field is not there. There's only like sporadic kind of localized fields. So radiation would be a problem, but we studied radiation in a bit more detail, so that we realized that it's kind of similar to the model radiation some people get here on Earth. And yeah, it's still getting quite a few satellites in the recent years, but nowhere near what Earth has. And then we looked, of course, at the atmosphere. And also, it's quite funny that on Earth, the sky is blue during the day and orange on Mars, but it's kind of reversed at sunset, where on Earth it gets orange and on Mars it gets blue. Yeah, it has much smaller moons. And let's say on my side, I am not exactly sure how, let's say, the Mars is impacted by having these kind of smaller moons. As I understood it, the moons kind of give a bit more stable orbit to planets and more stable, but I might be wrong, since I'm not an astrophysicist. Then we looked at the history of exploration of Mars, as we're kind of developed our way of kind of landing there kind of safely. NASA has kind of quite a good track record now, and all of their probes have lived quite a long time there, and they've always kind of went way above and beyond what was expected in the beginning. And now it seems like everybody on Earth kind of has seen a picture of Mars, and in some ways you can kind of think that it is a bit similar to some places on Earth. It's been quite a joy to see some of these images, and somehow Mars has become less of a kind of a foreign place, and at least I guess for people who are kind of passionate about the subject, it seems like it's almost a little bit more familiar somehow, kind of space. But it is also kind of, when you see these pictures, it looks also new. And there's a lot of kind of formations that look very interesting. We looked at craters as kind of good opportunities for having a bit of built up space. We looked at other geological formations around here, just to kind of get inspired for what we are about to do. Yeah. And we also try to understand a little bit more, like, what are the considerations that have been discussed of where to land on Mars. Of course, as we understood in the north, that there's a big ice cap, so that we could get water there, but there's this huge ex-ocean, and there's been some places that have been discussed, have been where water has been discovered, and it also seems like closer to the equator, where it's warmer, would be better. We also looked at all of the places where NASA has sent their uh, uh, their their voyagers, and also to kind of understand where the interesting areas were and why, and also where are the, let's say, the next places where NASA is considering to send things. Also, it was quite interesting for us that let's say the deeper canyons are a bit safer against radiation. Um, and hello, can you still hear me? Fine. I got a message that something might have changed.
We can hear you.
Okay, good. Then we looked at what SpaceX was saying, that to take something from Earth to low Earth orbit would cost about $1,650, which, I mean, is somehow, I could imagine that if I really wanted to, I could save $3,000 and send 2 kilograms of something to space, and that kind of sounds that we're getting into territory where it is kind of economically feasible to send something in outer space. And to Mars, we think that probably the cost is going to be a kind of order of magnitude higher because of the distance, but it's still quite interesting. We were quite inspired by the book of Robert Zubrin, and also by Roald Amundsen, who was the first person to be able to go to the North Pole. And the philosophy there was how to live off the local environment. And we looked also on Earth, how people live in kind of extreme environments, and how, let's say, we have developed, because humans have developed architecture, we have developed technology to be able to live in different, let's say, environments. And Mars, at the end of the day, is just a different environment. So we started with this research of like what has been the wisdom that has been accumulated on Earth about the living here. And there's these troglodyte houses, these underground houses, semi-carved in to the earth in Marmata, Tunisia, that are quite interesting. And you can see them also in Libya, and it seems to have been kind of a nice, kind of a successful way of living when you have to deal with kind of extreme temperatures. Also, another example has been, as I was talking about, like the edge of the canyons. We saw in Arizona, you have this place in Mesa Verde, where you have kind of shelters that are kind of on the carved into the edge of the cliff. Then you have this kind of adobe structures, which is just earth shaped into a house. And of course, we had to look at the way the Eskimos live, and how they kind of create this can also sometimes create these communities. And also they have some very interesting strategies about preserving heat, and controlling the airflow within their buildings, which has been something that was quite interesting to us. And somehow we felt that if we take this kind of traditional wisdom and how it has kind of become kind of more advanced with the technology. We kind of felt that there's kind of inflatables are one obvious kind of evolution of these strategies. 3D printed structures are also another one. And of course, we see kind of carved out buildings that are maybe not so popular these days. But we see them, we see kind of that there is technology that can enable us to create quite efficiently things that have been done also in a vernacular way. And of course, we continued kind of looking at what it will mean for a human. We might not need stairs because we can jump a lot higher on Mars. On Mars, because of the low atmosphere, we will have to create more structures that can withstand pressure and kind of are good with in tension rather than compression. We also looked at maybe like at the where the highest settlement on Earth is at 5,100 meters, where it's like half the pressure that is on Earth, which would lower the forces and the materials needed to build a settlement on Mars. We looked at the Skylab, where they had, because of the very low content of oxygen, they had to have a very high percentage of oxygen compared to normal atmosphere, and that made it a lot more flammable. So it was quite a risk. We also looked at the radiation, where we saw that if you spend only 4 hours a day on the outside of Mars, that would be kind of, you would get about 18 millisieverts, and that's kind of comparable to what a pilot of the crew of an airplane gets a year. So we think that if you spend only 4 hours outside the day, you should be fine, hopefully. And we looked at that the average American only spends 2 hours outside every day. So in theory, we should be fine. I mean, people should get enough. They can actually spend enough time outside, more than they spend here on Earth, actually. We looked at how 3D printing and what are the natural shapes that it creates, and also the advantages of 3D printing, because it's actually, it can easily create this kind of more curvy shapes that can lower the material usage by 11%. We looked at the sphere as the surface to volume kind of more efficient kind of geometry compared to the other ones. Of course, the capsule was also kind of quite close in the running. So we kind of created, first of all, kind of this geometry typologies to kind of consider, to kind of play with. And then we said, like, okay, how can we build these, and how can we kind of use, because if you just create inflatable structures or carved out structures or 3D printed structures, none of them will have, let's say, all of the let's say requirements that we need for a settlement on Mars. But if we kind of create a combination of all of them, we think that we can create a type of settlement that is the best of all worlds and kind of checks all the boxes. So what we imagined is that one of the big, of course, you can spend 4 hours outside, but there's solar storms and other radiation events that are quite dangerous for long-term habitation. So you have to create kind of almost this kind of transition between areas that are more protected and areas that are less protected, where you can put, let's say, less critical elements outside. And so we imagine that you'll have kind of almost like you will sleep in kind of underground, carved in places that are kind of very well protected against radiation, no matter what type of radiation event happens. And then you will have a kind of outdoor areas that are kind of very well protected, and then large kind of open spaces that are that they have decent protection. And these parameters created a few different typologies, and we realized that in order to create these kind of half domes, we need to have kind of a composition of the Earth that can withstand the forces of anchoring down this inflated structure. We also realized that the same way we here on Earth, we consider like emergency scenarios, like fires, earthquakes, and stuff like that. One of the big things that we will have to consider, both on the moon and let's say more likely on the moon, but also here on Mars, because there's still quite a lot of, because of the density of the atmosphere, there's still quite a lot of meteors that make it to the surface. You will have to have, let's say, a lot of redundancy between these habitats, and you will have to have some kind of protected zones in between. So we imagined, and you will also need to kind of allow for these kind of shapes to grow. And then how can you create shapes that can be expanded when they're kind of pressurized? And that was kind of another problem. And what we came up with is that we make these kind of 3D printed shapes in between that can also help strengthen the anchoring for the domes. And then that will kind of how to say, they will be built, let's say, around the structure so that they can create kind of a safe in-between space. If this, for example, if this dome gets shattered, then the next one can survive, and then people can get to safety in these slices, these in-between slices, quite fast. And then the next domes will not be affected if this one gets destroyed. Okay. And then we think that with this kind of strategy, you can potentially build a settlement that could house about 1,000 people. But let's say the bigger you make these domes, you're gonna run into like a lot of redundancy issues. So we don't think you can make them bigger than, let's say, a diameter of 80 meters, which is something that has also been done on Earth with large inflatable stadiums and inflatable structures on Earth. So we have experience with that, and we think that would be kind of a limit what can be done. And past that, if we want to create like a much bigger let's say cities, or we will need to kind of create these kind of donut structures that would have, let's say, they will need to have some kind of in-between structure, so that if one portion of this donut gets struck, then the other one can survive, at least for a while. And then past this, we imagine that we can have cities of up to 1 million people if we can create this kind of structure of donuts. This is actually what's simulated with by inflation and using so the structure, the external structure would be ETFE with Kevlar cables in between, and it was simulated as an inflatable structure, and it should work. One of our colleagues from Big has also made a paper about the physics of creating such structures in low pressure environments where we have to create big pressure inside. So in our kind of, let's say, 100 years timeline, we saw that initially we would have these single domes, and then we can create it when we have big 3D printing machines that we can bring to Mars. Then we can create these bigger domes that can be connected. And then past that, we can create this kind of the toruses and fused toruses kind of cities when we want to create large settlements. And one of our, and then we kind of started making these visualizations, showing what it would look like. Our client was the municipality of Dubai, and then they were saying that, you know, we live in the desert, we live in a place where it's very hard to live on Earth, and we think that if our let's say citizens can let's say get into this mindset of create that here they will have to create an artificial kind of way of living, and if we can do that for space, we can also do that for their living here on Earth. So it will solve both of their problems. And the approach that they were taking was to create a prototype here on Earth, because of course we don't know how things will evolve. And we saw that, for example, with the Mars rovers, there's always an analog on Earth here where scientists can look at it and see what works and what doesn't work. And when they run into problems on Mars, they can think of how to solve them here on Earth. So we thought that that's also what we need to do kind of on Earth. We have to have, especially in the beginning, kind of a mirror image of what we would build on Mars here on Earth. But here on Earth, the first thing that they wanted to build was something that will also get their citizens and the people all around the world kind of more familiar with the subject. They wanted to create almost like a university of people that would research this topic, but they would research it in a space that would be built the same way that we would build on Mars. And it would be 3D printed with local soil, and it would be a place of research, a museum, and a place of education. And we would build it exactly the same way we would build on Mars. We would dig first to get materials, then we would 3D print with the local sand, and then enclose these sections. Then we would enclose them with inflatable structures to create a better working environment for people inside. Then we would start to 3D print the internal structures that can also be torn down and then 3D printed again. As we know, let's say there's a big issue also here on Earth with the houses that need to be always kind of upgraded because society evolves and our needs and how we inhabit buildings changes all the time. So it's kind of a good strategy to create large buildings where it's easy to reconfigure inside. Yes, so then we could extend this process to the other buildings, and then we wanted to create this park on the top of the buildings because food is kind of half of the equation here for people to survive. And also in the papers that we read about the long-term habitation, it seemed like access to nature, being able to see outside, being in large open spaces was quite an important thing for mental health. Yes. And this is kind of a simulation of how it would look here on Earth in Dubai. And then, for example, this would be like also potentially a shelter where you're underwater, and then water is like one of the best protectors against radiation. And it would also be almost like a window to not feel like you're in a cage if you have to kind of go underground and protect yourself from a solar storm. But yeah, it would be almost like a lab for learning how to grow food completely sustainably. The air would be completely controlled so that air and water is all recycled, and all the nutrients, and you would have to create all, this nutrient cycle to feed people, and then make sure that there's always enough to grow new plants. But we felt that creating, let's say, a very positive looking kind of image of living on Mars would be something very beneficial, because until now, a lot of the imaging has of potential habitats on other planets has been this kind of almost like these metal boxes, which are not very appealing to people. But of course, we realized that you know, as we develop this and as we get more and more experience, we will add to this kind of prototype more and more modules where we investigate different ways of doing things. And we know that this is not going to be the final solution, and we're going to have to find new, and it's going to be a kind of constant process of iterating. And we also, yeah, did a lot of like simulations for about air and how we would deal with, let's say, all of the installations. And for example, here on Earth, it would be like a really big problem for overheating, and how to be able to create a space that kind of can reject, how it can create a transparent dome structure that can also become opaque in the end, because there's these inflatable pillows, and then in between them there is one that have these kind of reflective panels, and then there's one in between that is by regulating the internal pressure in the pillows, you can make it kind of cover up completely the exterior and have a completely reflective surface on the outside. And let's say because this was presented in World Government Summit presentation, what we wanted to kind of reiterate was that some of the most important sustainability development goals that we have is food production, drinking water, renewable power, consumption, responsible consumption, sustainable cities, innovative infrastructure, and understanding life on land and on water, and kind of dealing with climate. These 8 are some of the most important things that we have to solve here on Earth. These are also some of the most important things that we need to solve on if we create the habitat in space. And in space, we would have to reduce the land area usage for food by tenfold, by creating a lot of more advanced agriculture. On Mars, we have like only a small fraction, like about half of what we have here on Earth of drinking water. Here we have 10 million liters, 10 million cubic meters of water. On Mars, there's potentially only 5 million. And it is surprising that it's actually quite a small percentage compared to all the water on Earth. On Earth, we use a lot of combustion energy, while because there's the CO2 atmosphere, nothing can really burn. So we would have to kind of rely on nuclear, solar, geothermal, and wind energy. There is to our understanding, there is also some opportunity to harvest wind energy at higher altitudes. Of course, solar is reduced compared to Earth because of the distance. So we see nuclear as a quite important one, and also solar is not so. It has a problem when we have dust storms. They can cover half the planet, and they can last for weeks. Then geothermal would be also quite an important one if we can find geothermal energy on Mars. Then, of course, because it costs quite a lot to bring every kilogram on Mars, then nothing can be really lost. You cannot, like 1 kilogram of waste is actually kind of quite an expensive thing that you have to reuse as much as possible, and you cannot really lose anything. You have to kind of create this very tight circle where you're not really wasting anything. And today we create cities that are dependent from for resources that are brought from all over the world, while on Mars we would have to create these very self-sustaining cities that are kind of gathering resources from close by, especially initially. And I think that is a kind of a good model for how we can build cities also on Earth more sustainably. And let's say on Mars we would have to develop infrastructure completely from scratch. So we would have the opportunity there to use the most advanced types of transportation compared to Earth, and then create a new type of infrastructure there. Then let's say one of the biggest, like on Earth, humans have tried to mess with the ecosystem quite a few times. There's been quite a lot of examples of failures. For example, with introducing species from one continent to another. Like I know that starlings that were not native to the US were brought sometimes in the 1900s, and then they have grown to very large populations, and then they destroy quite a lot of grain fields. But for example, here on Earth, there's a kind of this famous example of in Yellowstone Park, how introducing one species can actually influence the geography of a space, where you can, like, there were a lot of deer in the Yellowstone Park, and they were grazing everything. They were just eating up all the grass, so nothing could really grow. So the park rangers introduced a few wolves in the area that started to control the population of deer, so that the forest, then when the population of deer was controlled, then the forest was able to grow again. And then the river was also able to develop. So the whole geography of Yellowstone was influenced by reintroducing wolves there. So let's say here on Earth, the environment is very delicate, and the kind of understanding it is a very complex task. While when we are healing on Mars, we would create an environment completely from scratch. So there we have the opportunity to kind of like really do it step by step, and then really understand all of the how to say it, all of the consequences of creating a new ecosystem. And then every one of these bubbles will probably become a new ecosystem in itself. So there will be a lot of experimentation in creating ecosystems on Mars, and that will help us better understand how our ecosystem on Earth works. I think the environment on Mars is pretty extreme compared to Earth, and being able to build structures on Mars will also allow us to build better structures on Earth that can withstand the different climate changes. So hopefully we can terraform Mars and get it to be kind of a second Earth, as we kind of, there's speculation that it was before, to kind of bring it back to its former glory, and kind of just also help Earth kind of deal with its current problems. And hopefully people will be looking from both sides of this picture in the future. And yeah, I have to thank the Archangel Group and government of the United Arab Emirates who have sponsored all of this work. And yeah, that's it from me. I'm really curious what you guys think about all of this.
Dimitri, there's a couple questions in the chat, and perhaps I see that Olga has unmuted or temporarily. But one question is from Wanda. She had posted that, have your architecture studies considered the limitations of Martian topology? The flatter areas seem to have more limited ISRUs access based on MRO gamma ray data, or was it the assumption for terraforming?
No, we haven't assumed the terraforming. We assumed that initially we will bring everything that we need. We will find, let's say, a flatter area, and then we will map all of the resources, and then we will have to accommodate the topography, even if it's a rougher topography. Inflatable structures are quite good, I think, with dealing with topography. And also, I think we can also dig into, as we expand our capacity, we can bring tunnel boring machines and large 3D printers, and also machines that can grind a lot of regolith to create construction materials and gather resources. But that would be kind of, it would have to be a plan, and that plan will of course change over time as we see which are the best areas to inhabit. So I think that our strategy can adapt to a lot of typologies of terrain. So it's not limited, let's say, flatter areas.
What about the recycling materials and essentially reusing waste from the habitants of this settlement and using it for more positive, other than kind of a landfill type storage?
Yeah, so we think first of all, there's as we said that the nutrient cycle is quite important. I have a friend here on Earth who literally buys shit, like that's his job. He he buys shit as fertilizer, and yeah, like we I think on Mars we would have to consider fertilizer plants, and spaces that can produce fertilizer in order to keep the plants healthy, because the soil there needs to be the all the nutrients in the soil need to be regulated. So let's say with this kind of normal waste, let's say the food waste, it would totally be recycled. And then in terms of materials, I think like because like especially high materials that are very you need quite advanced industry to 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 manufacture them would be quite precious. So you would have to like especially like rare metals and all of these things, and the kind of advanced materials you would really want to recycle as much as possible, and potentially you would have uh, robots that would only do this, and humans would really have to think of not really throwing anything away. You would really have to have a recycling facility.
Okay, thank you. There's a question from Jerry Brown. And have you thought about developing a data warehouse for use in long now projects that would provide a foundation for current and future space ventures?
I don't know exactly what is a data warehouse. I think especially in architecture, there's a lot of necessity for data gathering and also collecting data about how people respond to different spaces, how people how to say use different objects, and like I think data gathering in design and design spaces is something that we as architects have been quite lax on using, and right now we're using unfortunately quite a lot of experience that was gathered over very long periods, but might not reflect current situation of field architecture. So we need to get better, and we were trying to have some collaborations with companies that are developing Internet of Things, the Internet of Things, in order to gather more data on how different spaces work. Yeah, in order to get more data about architecture.
Thank you, Dimitri. Question from Will Bolton. How have you estimated how large the sustainable population of Mars might be?
Initially, we imagined that you will have what is very important is the community, and we imagine that 160 the first domes will have like 20-30 people, and then they can probably grow up to 160 people. But as we go as technology gets more and more advanced, I don't think there will be a sustainability problem per se. it should be the most sustainable, let's say, type of living. Let's say probably the moon will be even more sustainable than Mars because there's even less resources there. So you have to have like a very tightly integrated system. But and it's even harder to live on the moon. But let's say I think the the first buildings on Mars should be more sustainable than any building built on Earth today, probably. That's my theory, at least.
Okay, well,
Oh,
I think it's a great theory. Yeah, it's a great, because then hopefully that will be the case because we are building from scratch. So we can should leverage the best of the best that available at our design studios. Chris Savage has first he complimented amazing, cheers, and asked a question. Have you considered the operational and or maintenance technologies to sustain the habitat over time?
yes, we consider some of them, and especially in terms of let's say maintenance. That's why we made everything as modular as possible and being able to even destroy buildings and stuff. The let's say hardest to maintain things and the hardest to change things would be the carved out structures. And those will have to be the more where you kind of think the more in the longest time period. Um, but with the where we place the most let's say thinking was in these kind of 3D printed structures that can be quite flexible, which is good. And also in terms of maintenance and also in terms of the domes. We thought that you have to be able to evacuate them, you have to be able to have some of them become operational in order to perform different maintenance. And then we also made this structure that has this skin that has several layers of protection, so you can work on different ones of them. And then fortunately, because pressure becomes more important than gravity, and when you have faults, the dome itself will it will take quite a lot of time for it to deflate. And then I think we will, and since gravity is a lot less, and since it's a kind of light structure, it should be easy to hold up. But yeah, I think that's also the purpose of building a prototype on Earth, figuring out the things that we haven't thought about, of course.
And I see that Olga Banova has a raised hand. I think she has a question, maybe. Olga, would you like to ask or type a question?
Yeah, thanks. Thanks for the presentation. I have, of course, a few questions. Hold on, I turn my camera on. First of all, thanks for mentioning power in the end, because I think that is something that's to be first considered. Everything requires a lot of power. And but question one is, have you looked at Biosphere 2 as a prototype to see what didn't work and why it didn't work? And another question is about site preparation, because for such a large structures, doesn't matter what site you consider, flat or not flat, there is no perfect site on Mars, obviously, so it requires a lot of site preparation first. So did you calculated that or considered it in your architectural studies? And well, and I think the
can I
most
answer the questions
interesting
one
that,
by one?
yeah, sure, sure,
So I
sure.
don't
And then I
forget
have a third one, is
don't
if
forget the
it's
question.
okay.
Yeah. So the second question was about the site preparation. What we considered for long term would be that first you would have a dome near where people can already live, and then you would have a lot of machinery that is able to do the site preparation by itself. So you would have robots that would prepare the site for you. Because you don't want to have you don't want to have humans doing this kind of work in kind of spacesuits, because that would be too cumbersome. So we will have to develop robots that can prepare the site for us. And the whole 3D printed houses movement here on Earth is I think kind of a good experiment on how to do that. And I know that the BRK Ingles is working together with Icon, the 3D printing company, to develop this kind of thing for the moon. And I think they have a contract with NASA about that.
Yes,
And
I
what was
do.
your first
And
question?
the first I said, like, if you consider biosphere and looked at biosphere too, you said
Yes.
yes, it's good.
Yeah,
So I
we
guess
looked,
yeah.
we looked quite a lot of it at it, and that was one of the reasons why we think. I mean, we don't have the answer. We are not let's say biochemists or let's say agriculture engineers, but we uh, that's why we said that half of the building basically needs to become, let's say, like a laboratory for food, because and I think, well, part of it was like for create, like, let's say, a nice environment to live in, but also to create, let's say, a better relationship between us and plants, because on Mars, if those plants die, people will die. So they need to be very kind of connected to their food source, and everybody needs to take care of the plants that are ensuring their survival somehow.
It's quite different in airtight environment and pressurized environments, so it's not exactly the same. And there are certain issues that will affect human living if you really share it with plants, not necessarily on the positive way. But anyway, so that was, and again about power source. Why did you consider wind power on Mars? It won't be effective at all. The atmosphere is too thin, and it will require huge structures as
What
well.
we understood is that at high altitudes, because you need you probably will, unless we find geothermal, which is very stable energy source, everything needs to have a backup. So if here on Earth, we always consider that if one thing fails, you need to have another backup. And we thought that you can. There are these prototypes that are very lightweight. That they're almost like balloons, and they function as a windmill, and you can have them sit very high up in the atmosphere, and there's enough wind speed there that you could theoretically generate at least some power. We were we were sure that this would be a contention point for people, but we didn't want to discount it, because it might be in some situations like the last resort kind of option. If you have a dust storm and your nuclear thing goes down, then you might need to send up these balloons to just have some power.
Okay, thank you.
Yeah. But we realized our project is not perfect and needs to be developed, and
There is
that's
no such
the
thing as
whole
a
point.
perfect. There is no such thing as a perfect project, a perfect
Yeah,
house, a perfect
yeah.
habitat. That needs to be.
But we are looking forward for people to actually start creating these prototypes. I think Biosphere is a really good example, and I think we need to do more of these attempts. And I think
Well, it's yeah.
with the outlet of now having a lot of hydroponics and all of these technologies, we are a bit closer and having a lot more experience with airtight kind of
Well,
infrastructure.
yeah. In reality, probably for 1 million people, if you provided housing for 1 million people, it will require at least triple size of the structure to support it 100% food requirements. That would be probably the result. But anyway, yeah. Thanks.
Thank you, Dmitry, for really great presentation and all the information from your project and what you learn while you're researched in preparation and executing the project. Do we have any other questions from other attendees? I see Mike. Mike, you have a hand up. Go ahead.
Yes, Dimitri, is a very good presentation. I thank you, and especially the ideas of how this a big settlement can evolve from something small. And I think you're right. The key is robotics. Also, the idea of doing some of these domes to start on the Earth and changing some desert land on the Earth to big cities eventually, but trying how to manufacture these things on the Earth first. You would learn a lot, and that would also provide living space for a lot of people on the Earth, which is needed. But my question is has to do with the financial end of it, or the economic incentive end of it. You know, back in the days of Columbus, he sailed out into the ocean to find a better route to India for the economics of it, and that sparked the whole area of discovery that ensued from there. So, do you have any idea of what kind of economic factors can bring about these Mars settlements, just to start them at least? It would be good to have some idea and outline some of that and show how that could evolve into big Mars settlements.
Yeah, I think also there's these books called Red Mars, Blue Mars, Green Mars, and they have the right of it. A lot of it probably will come down to mining and the resources. There's quite a few resources. Even like you would be surprised here on Earth, because sand is becoming kind of a resource that we will at some point not have. Sand for construction, for building concrete, will become a problem at some point. There is some discussion about it in architecture circles. So, and of course, we are thinking also building in wood here on Earth, but there's a lot of advanced materials that there's not so much on Earth. And the more our technology evolves, the more we need them. And of course, we need to be able to get, and they might not be on Mars. They might be in the how do you say, the asteroid belt, where you have quite a lot of resources. The abundance of resources will also create an economy, might create an economy of abundance, where let's say we'll kind of we are going, I think, more and more towards an economy where ideas and knowledge is more important than resources itself, and kind of going towards that economy might become, let's say, a more sustainable way of living long term for Earth than just depending on resources that if you think on a universe scale, resources are very available when you think beyond Earth. While knowledge right now is just held here on Earth, and if something happens and we can't deal with like let's say big problems with climate problems and like economical problems and societal problems, we can't deal with these here. And for example, I know right now I was reading that in Texas there's a lot of big issues with electricity because they can't cool the enough the spaces. They have a lot of demand for cooling right now. So in the future, our energy grids will have to improve in order to handle this kind of pressures better. And these are problems that we will have to that we face daily on a daily basis on another planet. While here on Earth, we live on a very Goldilocks kind of planet where every little difference makes a huge impact on our daily life. And we have to realize that it's a very fragile equilibrium that we're living in. And if we are able to live on different planets where the conditions are much broader than what is here on Earth, then we will be able to live here on Earth no matter what happens. You know, if Earth turns into Venus, then we will still be able to live here. So we will not have to abandon Earth, let's say. But we need to be able to learn how to do that, and that is by trying.
And I think that's a
to
key
do it.
point. In going to Mars, we will learn a lot about how to survive and how to make the environment livable. And and that knowledge coming back to the Earth may help the Earth out quite a bit in the future, long-term future. So I think that's a good point.
And we don't want to, and we want to be able to experiment in a place where we're not going to destroy all of human society. Let's say if we do something to Mars, that is, we realize that it's a bad thing. We might not want to do that on Earth because it's such a fragile thing. I mean, I don't know. Now we're going quite speculative discussions, but I think Earth is very precious environment, and we want to be very careful what we do here. And we need safe places where we can experiment, and space is very abundant with that.
Sorry, I have to say, planetary protection people wouldn't agree with you. It's like, now you want to destroy Mars.
No, well, I mean, that's not the point. But
It's better than to-
every place and every planet is important, and I'm sure that's not exactly what Dimitri meant. That Mars and Martian space
but what
and
I meant is
environment
that
is
couldn't help.
yeah, we have come to a point where we actually can do that.
that.
We have come to the Anthropocene, where humans actually have the power to destroy planets, unfortunately. And we need to realize that, and we need to make sure that we don't do it to Earth.
I think also one of the most important things that if going somewhere and doing somewhere else in more harsh environments and new environments, we definitely learn more about ourselves, and hopefully we'll figure out our issues and problems that caused by ourselves. But and sure. Can really live better in harmonized environment and harmonized societies. So that is another issue. Okay.
I really wanted to point to what Dimitri had brought up, and Olga, you just kind of reinforced that too. It's the two major key points is the knowledge acquisition and technology development. And the exploration does basically feed into those two, and as a synergy, and creates a solution that we can use both into the exploration of the space exploration of other planets, as well as using it as a dual technology on applying to Earth. So that is a tremendous outcome from pretty much anything we had done so far in any kind of exploration, but space exploration in specifically.
Question for you, Dimitri. Great presentation, thanks. What do you think of Elon Musk's ideas of going to Mars?
I think for now, it seems like he's more focused on getting there. And then I think he's not ready to, I think the thing, one of the things that we, let's say, some people, let's say there's this kind of classic paradox that the longer you wait for technology to develop, let's say the faster you're going to be able to get to where you want to go. So you want sometimes you question like, okay, so we want to go to another star. If we wait another 100 years, we're going to get there in half the time than we would if we would leave now. So there's always this question about waiting the right moment to go somewhere else. But if you don't start, you're never gonna get there, of course. And I think right now, from what I know and what I've seen, Elon hasn't really put much thought into like how we're gonna live on Mars before he's actually able to know what vehicle he's gonna get us there with. So I think unfortunately the vehicle is kind of a very big limitation of what we're gonna be able to bring there, and getting that in place. And of course, by the time the vehicle is done, let's say the technology is gonna be improved. But I also think that he's very ambitious about the time to get there. And I think he might be underestimating a little bit how much research it takes to create a properly livable environment. I think he's getting a little bit of experience now by creating a completely new settlement in Boca Chica for all of his employees and setting up like almost like a city there. But and then probably with the NASA's plans for the moon, there's going to be another experiment. And I hope he will also create a lot of prototypes. And he's quite good with making prototypes. And I hope he's going to make city prototypes as well, starting as soon as possible, because human research takes, and human behavioral researches and developing food technology takes quite a long time to develop, and it might take more time than actually developing rockets. So starting as soon as possible will be beneficial.
And another answer to Dave's question is, as you guys might know, Elon Musk has announced that his next big thing will be robotics. And he wants to do a robot that can service the human needs. In other words, have robots that can do what you were suggesting, Dimitri, in using robotics to do the construction work on Mars. So you don't have the spacesuit or other factors that go into humans to do the work. And the other thing is, it strikes me that Elon Musk in particular is the kind of person that he doesn't have to think it out a lot ahead of time, because he's the kind of a person that could invent his way of surviving as he goes. He says, don't worry about it, we'll fix it, we'll invent it as we go. And that's probably a little bit erroneous, because you need to do a lot more, planning ahead, like Dimitri is doing, without in order to make it successful. And living off the land is the key point. So I think Elon realizes that, and then he probably will get around to it. But his first thing is to get the robots working So they'll do the work for him when we get to Mars, hopefully.
And
That'll be
hopefully we
helpful.
can share like this, we can have a lot of these discussions and have a lot of experiments all over the world, because I think if you want to do it in a reasonable amount of time within our lifetime, let's say, then we need a lot of people working on it. Because and I think the COVID pandemic has been kind of a good example where you see like the whole world working on one problem is a kind of a really good produces really good results.
Yeah, those are all good thoughts. Thank you.
Yeah, thank you so much. And thank you, Dimitri, for again, for coming. And I invite everyone to attend a future SpaceGeekSpeak meetings every Saturday. As I said, we meet, and Dimitri has been participating in number of Saturdays. So we have impromptu discussions both about sustainability in space, and going to Mars and going to Moon, and just about anything in between. And so thanks everyone for attending, and Dimitri for presentation. I will, after this meeting, I will post this recording onto SpaceGeekSpeak YouTube channel. And with that, we'll see you next time.
I've also posted my email in the chat if somebody wants to write me or has further questions or anything. But yeah, I'm looking forward to seeing you next Saturday. And
I will,
and
yes, if Dimitri, okay, I will post it also on as a YouTube supplemental material, so then it will be available for communication.
Yeah. And Mike, I've looked at your proposal, and I think we can hopefully collaborate on doing that little video.
Okay,
So we
thank
can
you.
talk about it next week.
Okay, let's talk. All right, thank you.
I'll have a bit more information about it.
Okay, good.
Okay, cool.
Okay, so if there's no more questions, then I would like to wish everyone great weekend, and we'll see you next Saturday.